Okay, number 10. We have an oil can that can be made from a right circular cylinder, so it's like a can, right? Okay, and it's containing 6 pi cubic inches, so the volume is 6 pi, how about I write this right? Volume equals 6 pi inches cubed. All right, and it says what dimensions of the can will require the least amount of material while meeting the requirements for the volume. So they want the volume to say 6 pi, but they want the least amount of material. So let's do surface area of a cylinder. That's equal to the top and the bottom, which is 2 of them, and then it's the area of a circle, pi r squared, plus the area of the middle part, or the surface area of the middle part would be the circumference, which is 2 pi r times the height, if this is height, and this is the radius. All right, well, we have 2 variables in here. We have r and h, so let's get rid of h by using the volume. So the volume of a cylinder is the area of the base times the height, which is pi r squared h. So that's equal to 6 pi. So h is equal to 6 pi over pi r squared, or 6 over r squared. So replace that in surface area. 2 pi r squared plus 2 pi r, 6 over r squared. So we can cross out the r's and just have one r on the bottom. So we get surface area equals 2 pi r squared plus hang on a second. It's 16 pi, not 6. So 16. So plus 32 pi over r. Okay, so plus 32 pi over r. All right, so now the derivative of that would be 4 pi r minus 32 pi over r squared. Set that equal to 0. Okay, so you get 4 pi r cubed minus 32 pi equals 0. So 32 pi equals 4 pi r cubed, so r cubed equals 8, so r is equal to 2. The radius equals 2. Now the height compared to the radius was up here, so the height is equal to 6 over r squared, so 6 over 4. So the height, it's 16. Remember, I changed that. 16 over 4, which equals 4. So the radius would be 2 inches and the height is equal to 4 inches. So that was the answer to number 10.